Have you ever heard that a neural network is just math? It sounds a bit dismissive, right? Like saying a skyscraper is just a pile of bricks. But what if I told you that simple idea is the key to unlocking how these incredible things actually work? Let's break it down. No complex equations, I promise. Imagine you're trying to decide if a picture shows a cat. What do you look for? Whiskers, pointy ears, a certain eye shape. Each of these is an input. In a neural network, these inputs aren't just pictures, they're numbers. Maybe it's the pixel values from an image, the words in a sentence, or stock prices over time. Now, not all clues are equally important. Whiskers are a much stronger clue for a cat than, say, the color of the background. So, the network gives each input a weight. Think of it like a score for how important that piece of information is. A high weight means pay close attention to this, and a low weight means this probably doesn't matter much. The network takes all these inputs, multiplies them by their weights, and adds them all up. This is the weighted sum. It's a single number that represents the combined evidence, but a single number isn't very useful on its own. Is 57 a cat? Is negative 123? We need a way to make a decision. This is where the activation function comes in. It's a tiny decision maker. It takes that big weighted sum and squishes it into a more useful output, usually a number between 0 and 1. You can think of it as a switch. If the sum is high enough, the switch flips on, maybe outputting a 1, which could mean yes, it's a cat. If the sum is too low, the switch stays off, outputting a 0 for nope, not a cat. It's a simple yes or no, fire or don't fire decision. Now, here's the magic. A single one of these units, input, weight, sum, activation is called a neuron. It's simple, almost dumb. But what happens when you stack them? You create layers. The output from the first layer of neurons becomes the input for the next layer, and that layer's output feeds into another, and so on. The first layer might learn to spot simple things like edges or corners in a picture. The next layer takes those findings and learns to recognize combinations like eyes or noses. The layer after that combines the eyes and noses to identify faces. By stacking these simple units, the network can learn incredibly complex patterns, far beyond what any single neuron could ever do. It's like a massive, automated assembly line for information. So, how does it learn? This is the training phase. We show the network thousands, even millions of examples pictures labeled cat and not a cat. Initially, the network's weights are random, so its guesses are terrible. But every time it gets one wrong, it gets a little nudge. An algorithm called backpropagation goes back through the network and slightly adjusts every single weight to make the final guess a little bit better next time. It's like saying, hey, you thought that was a cat, but it was a dog. The weight you put on floppy ears was probably too low, and the weight on pointy ears was too high. Let's tweak them. Repeat this millions of times, and the weights slowly settle into a configuration that's really good at the task. Once the training is done, the network is ready for inference. This is the fast part. The weights are now locked in. You show it a new, unseen picture, and the data just flows forward through the layer's input. Weighted sum, activation. Next layer, boom, you get an answer in a fraction of a second. All that hard, slow training pays off with lightning-fast performance. So, when you break it down, a neural network isn't some unknowable black box. It's built from incredibly simple units performing basic math. But when you connect millions or even billions of these units together and train them on a massive scale, they can achieve extraordinary things, from generating art to driving cars. It's a perfect example of how simple units, when organized at a massive scale, can lead to incredible, emergent intelligence. Thanks for watching. If you enjoyed this breakdown, give this video a like and subscribe for more deep dives into the tech that is shaping our world. See you in the next one.